Welcome to the open source software class again. In this video, we are going to see about general overview of Linux and the two modes, that is the kernel mode and user mode of Linux. The first topic is the general overview of Linux. The topics that we are going to discuss in the overview of Linux is, first we are going to see what is a Linux, then why need to choose a Linux, then about Linux systems, then the security aspects of Linux, and a few comparisons with Linux. Now, what is Linux? Linux is a 32-bit operating system, which is a Unix-like operating system, which was originally developed for the purpose of home computer or home PCs, but now it runs on a variety of platforms. As you know, the Linux source code is freely available to everyone, and the Linux was created in the year 1991, and now the Linux has at least 10 million users worldwide. Okay, next, why do we need to choose Linux? Linux distribution provides the software with worth thousands of dollars for free. A Linux operating system is a complete operating system. It is stable, reliable, and it's extremely powerful. Linux has excellent networking facilities. It has ideal environment to run servers such as web servers and FTP servers. It's easily updatable. It supports multiple processors. You can add n number of processors to a Linux system, and it supports true multitasking and multi-user OS. The next topic is about Linux systems. The Linux system excels in many areas, ranging from end users concerns such as stability, speed, ease of use, and it comprises of three components, that is Linux kernel, Linux networking, and Linux file system. These three components we are going to see in the next few slides. First is Linux kernel. The kernel is the central nervous system of Linux OS. It includes the OS code which runs the whole computer. It provides resources to all other programs that run under the Linux, and it manages all other programs as when they run. The kernel includes the code that performs certain specialized tasks. It includes TCP/IP networking. Then Linux networking. Networking comes naturally to Linux. Linux is a product of internet. Linux is specifically made for networking. All the networking protocols that are available can be used in the Linux. The networking protocols that are supported in Linux are TCP/IP, that is a transport control protocol, and IPS, Internet Protocol, IPX, that is Inter-Network Packet Exchange, Applet Talk DTP, and the last protocol is Level 2 of amateur radio. And here, Internet Protocol is the primary networking protocol supported by the Linux. And in Linux networking, the supporting features are forwarding. Linux has firewall operations. It has proxy, and you can do tunneling and intranets using Linux networking. Next is Linux file system. Linux has hierarchical unified file system. It supports 256 character file names. Okay, a file name can have up to 256 characters. All command line entries are case sensitive. In Linux, you have to use slash symbol rather than using backslash that we would be using in DOS. So in this, we have to use the slash. The types of files that are available in Linux are in ordinary files. You can have text files, data files, command text files, and exe files, that is executable files. The next type is directories. The third one is links. Links means rather than having multiple copies of a file, Linux uses a link to one file to save the disk space. And the last one is special device files. Okay, in Windows, we can compare these types as the ordinary files that we store in the Windows, such as PPT, Word file, that is called as the text files. And in Windows, we have the exe files as well. So as far as directories is concerned, these are the folders that are available in the Windows. The folders in the Windows are called as directories in Linux. And as far as links is concerned, in Windows, we can copy the same file in various places, but in Linux, to reduce the disk space, a file's link can be saved to some other space. Next topic is security of Linux. In this, we are going to see about encryption, SSH, that is secure shell, and the last is principles of security in Linux. As we all know, encryption is commonly used to secure data. It's a very old technique to hide information. In this Linux, you have two types of encryption. One is strong encryption, the next one is public key encryption. The strong encryption is stronger than a 40-bit encryption, and the public key encryption is a type of asymmetric encryption, which is a system that you encrypt your message with one key and the recipient decrypts it with a mathematically related but different key. The next is secure shell, that is SSH. The SSH and its tools use strong encryption to allow remotely located systems to exchange data securely. By using this strong encryption technique, SSH enhances the security of both authentication process and the networking sessions as well. Now, the principles of security in the Linux. As you might know, there are two broad categories of attacks. That is unauthorized access. The second one is denial of service. Now, the Linux uses some defense mechanism against these attacks. Some of them are enforce the use of passwords, as we are all done. Then we can use TCP wrappers to limit the resource that are made available to the categories of users. Okay, every category of user can be limited to the usage of particular resources. Okay, next one is monitor internal users, protect your organization against unauthorized access or inappropriate users of the computers. The next is operating system comparisons. Here you can see the comparison of Linux and Unix. Linux is free, but Unix is not free. Most programs written for Unix can be run or recompiled and can be worked with Linux. Linux will run faster than Unix on the same hardware. If a similar hardware computer you install Unix and you install Linux, Linux will run faster than Unix. Now the next is comparison between Linux and Windows. Yeah, the third one is Linux versus Windows NT. So you can go through this. The next topic is kernel mode and user mode of Linux. The topics that we are going to see is what is kernel, the kernel mode, then the user mode, the difference between user and kernel modes. Now, first of all, we need to know what is kernel. Kernel is the core of any computer system. It's a software which allows the users to share computer resources. Kernel can be called as the main software of the operating system. It may also include the graphics management. The kernel interacts with the hardware. Kernel is the first program to get loaded when the computer starts, and it runs till the session gets terminated or the computer is turned off. But it's different from BIOS, which is hardware dependent. But kernel is software dependent. You all know about BIOS. In Linux, in the hard disk, the kernel is represented by the file name, so by the file name VM Linux. Next is architecture of Linux OS. The next topic is kernel mode, which can be also called as privileged mode. The kernel mode can also be called as system mode. Yeah, there are two distinct modes of operation of CPU in Linux. One is kernel mode, another is user mode. Two different modes. The kernel mode is mainly used to restrict or protect the computer from unauthorized user application programs. When the CPU is in kernel mode, the system is assumed to be executing the trusted software. Okay, it only runs the trusted software. If any software that runs means the system or the CPU will assume it as a trusted software, and it runs. Thus, it can execute any instructions and reference any memory address. All other programs that is the user applications are considered untrusted software in the kernel mode. All the user mode softwares the user applications must request the use of kernel by means of a system call. In the kernel mode, if the user applications need to be run, it has to send a request by the means of a system call. An example of this would be device drivers. A device driver must tell the kernel exactly how to interact with a piece of hardware, so it must be run in kernel mode. Okay, a device driver example, a sound card or NIC, network interface card, anything, it must tell the kernel mode how to interact with the respective hardwares. Because of this closed interactions with kernel is also a lot more vulnerable to programs running in this mode. So it becomes highly crucial that the drivers are properly debugged before being released to the public. The next one is user mode, which is also called as non-privileged mode. In this mode, each process starts out. It's non-privileged in that it's forbidden for process in this mode to access those portions of the memory that have been allocated to the kernel or other programs. Okay, the process, it is non-privileged because the process in this mode has to access the remaining portions of the RAM that have been allocated to the kernel or other programs. When a user mode process wants to use the service of the service provided by the kernel mode, it has to temporarily switch to the kernel mode. When the kernel has satisfied the process request, it restores the process to the user mode. Okay, the standard procedure to switch from the user mode to kernel mode is called as 0x80 outer interrupt. Okay, user mode is the normal mode of operation of the programs. The web browsers, the calculators, and all the applications will run in the user mode. They don't interact directly with the kernel. Instead, they give a system call in. Instead, they give instructions on what needs to be done, and the kernel takes care of that rest. The code running in the user mode must delegate to system APIs to access hardware or memory. Most of the codes that run on the computer will execute in user modes. When in user mode, some parts of RAM cannot be addressed, some instructions cannot be executed, and some input output ports cannot be accessed. These remaining things that RAM that addresses and the input output ports will be allocated to the kernel modes. Okay. Difference between user mode and kernel mode. To avoid having applications that constantly crashed, newer OSs were designed with the two different operative modes. One being the kernel mode, as we all see. Kernel mode is the machine operates with a critical data structure, direct hard drive, that is input output or memory mapped, and direct memory, IRQ interrupt request, DMA, that is direct memory access, and so on. Okay, user mode. Users can run their applications in this mode. The system starts in the kernel mode when it boots, and after the operating system is loaded, it executes the application in the user mode. Okay, in every computer, in the Windows also, there will be a kernel mode. When the system starts, the kernel mode is turned on, and it will be running in the background. And once the operating system is loaded, the user mode is comes into place. And once the system is shut down, the kernel mode also will be turned off. That's it for this video. Thank you.